Hello. Thank you very much for coming. Can you hear me well at the very end? Awesome. So I want to talk today about Next. So this is not pure React. We're not talking about React, but this is very closely related to the React ecosystem. So I work at CircleCI, and we use a lot of Clojure script, right? Clojure script is a compiler for Clojure that targets JavaScript. Clojure, in turn, you might know, is a very nice functional dynamic dialect of Lisp. So Clojure script looks pretty much like this. There's a lot of parentheses, opening, closing, a lot of arrows, a lot of like weird stuff. Don't be scared. It's nice. It's great actually. And Clojure script is actually allowing us to do a lot of really cool stuff. So for example, we can get really good performance out of our application in comparison to if we were writing it in bare React.js, right? We can do code sharing between the backend and the frontend because our backend is written in Clojure. And so we have like a whole namespace of utility functions that we can use both on frontend and on backend. And we also can do interactive development. It's not really a game changer, but it's kind of cool, right? So CircleCI backend was written in Clojure since the very beginning, and so it made sense to just use frontend, use the same language on the front end if it were possible. And so at the same time wanted to use React, and using JavaScript directly from Clojure script is not that much of fun. I mean, you can totally do it, but it's not the best idea generally. And so then this thing came up, Om. This is a React wrapper for Clojure script, right? And everybody was like, yeah, amazing, this is happening. So this turned out to be one of our front end turned out to be one of the first production Clojure script and Om applications, and eventually one of the largest production and Om applications in the world. So right now we have more than 20,000 lines of pure Clojure script. This is not counting, obviously, tests, library is, that we are using underneath, not counting CSS even, all this stuff. So that's a lot of Clojure script. And this all goodness is open source. You can take a look at our front end in our GitHub profile. So as I said, Om is a React wrapper for Clojure script, and this is pretty much how you use it. So supposing that we want to write the magic hello world thing in React, first we do some kind of markup that we'll use that we will populate with React later. So this is nothing complicated, just a div right there that we'll use later. Then we write this. So first of all, we require a bunch of libraries that we'll be using. So you can see there is a Google library in there from Google Clojure utilities. Then there is Om DOM manipulation utilities and Next that I will be talking about later. Then we use this nice macro to define the component. We say that it will override a method of an object class. We tell it that it's going to be a render method. It's going to perform this action. It's going to go to the DOM function, the DOM namespace, and call the div function, going to create a div. And then we wrap all this into a thing called onFactory, which creates an actual React component. And then we call JavaScript right there, call React render, give it the component, give it the DOM element, and hooray, we have the thing. So this is how the result looks in the DOM. So this is exactly what you would get if you were using pure React. So far so good, right? So but why we're using Om is not just because we want to use Clojure script on the front end. It's because Om is not just a React wrapper for Clojure script. It's more stuff. So the thing that we find most valuable is built-in global state management. So you might have heard of Redux. And you probably are familiar with a lot of use cases for that. So probably you don't need global app state if you write only pure React components. But your components are probably not pure if you're doing anything useful in your application, right? Manipulating data on the back end and all that stuff. So sometimes your component's got to change the state of other components, which are completely unrelated to your current component. And that's where global state management comes into play. So, for example, an e-commerce website with a shopping cart, right? You have a product component right there. It has a button in there, maybe its own component, whatever. And here you have the shopping cart that has a products list, products in cart. And what happens is when you add a product to cart, you cannot directly update this component from there, right? This is not possible. But what you can do is have a thing called app state, and then you update that, and then you re-render the product cart, and bam, it has all the new data. So what Om does with this is it makes accessing and manipulating the global state easy. So this is the example that we were talking about previously. Let's change it a bit, and I'll go line by line. We added the app state here. So item is in the Klochay world is immutable state of data. So we give this a description of the app state. We changed the name of the component. Of course, it's no longer a hello world thing. It's a counter now. Here we start to get the properties of the component from the state, so that we can use it. We can change the component in real time. Then here we get the key called count from the app state. So the syntax there is a bit weird, but don't be scared. It's you can do it in simpler ways as well. Here, as you can see, you can already use the count variable, and so we can just get the value that was there in the app state. Here we just make a button, DOM button element, and attach some on-click events for it. So for example, this function will be triggered on click on the button. What it's gonna do, it's gonna go to the app state. It's gonna update the value count with a function called increment. So it's gonna increment the count from 0 to 1, from 1 to 2, and so on. This is a thing that will help us put the state into the component. And this is the actual thing that's going to attach the component to the DOM. So what happens is, after all this, we'll have something like this. It's going to be a real counter written in Om plus React. So this is the very silly usage of global app state. You could totally do this with like component state, right? This is completely useless. But there are actual real proper use cases for global app state. So for example, if you're as I said, if you want to update a state of one component from the other, or maybe you don't want to update data synchronously, right? You want to store some stuff in an application state and then send it over asynchronously in the background, and in the meanwhile update the UI with some intermediate result. Or maybe you want to load less data by reusing the same data in different components, right? You load it once, you use it everywhere. Sounds like Java, right? So this is Om. In addition, as we said, in addition to wrapping React, it implements the global app state out of the box and makes it easier to use. So this is Om, but I wanted to talk a bit about Om Next. This is a new thing that the creators of Om came up with. This is an incremental improvement upon Om, and it introduces some really interesting new concepts. So to start with, there is new component syntax. This is the example we were looking at previously. This is already the new syntax. The old syntax was just a bit different. There is like a small difference right there. It's a small difference, but it adds, in a large code base, it adds a lot of application. When you need to specify render and then render again, and then if you change the signature of one of those functions, you have to change the other one, and we had countless failed CI builds, if somebody changes one thing and not the other. So the new syntax is nice and clean, and it has the additional benefit is that the result of processing the component created with this def UI thing is the actual React component, which was not the case previously. So it's nice. It's good for debugging. It's useful. It's nice, but it's still minor. Let's talk about something a bit more major, like data fetching. So this is an actual production thing that we have on our website right now. If you go to project settings, there is a way to add an SSH key for your project so that you can SSH into servers for deployment, whatever. There's this add SSH key button in there. It's implemented underneath using all this stuff and more. Let's focus on one thing here that I want to talk about. So here, this is the we use the button component that we wrote. It's also open source. You can take a look at it if you're interested in it. What it does is, on click, it raises an asynchronous control event that in turn gets handled by a controller that performs that is called saved SSH key, which is the name of the action. And it calls sends the Ajax query to the server with a certain name. And then we have another controller, which is an API controller, which comes into action on success of that call, and then goes to the app state and puts the result of the Ajax call into the app state. And then we have another controller that acts after the previous controller and sends another, and then sends another Ajax request to update the new version of the project settings. So it turns out that that button is triggering a bunch of Ajax requests, right? So we trigger an event from the component that issues an Ajax request. Then we have another controller, another controller, another controller, right? That's amazing. And so with the new data fetching patterns in Omnext, this becomes slightly irrelevant. So there's a thing being introduced right now called Omnext Reconciler. So this is not the React reconciler that you might have thought about, but this is a thing that's going to sit between the server, the application state, and the React tree, right there in the middle. What's going to do is app state right now is becoming a tree, and the reconciler is going to manage that. The tree structure itself is inspired by GraphQL and is designed to be able to maintain correlation with GraphQL in the future. And the components, on their part, instead of just receiving props, they specify the data that they need to be able to function. And so this reconciler thing, we tell it how to fetch the parts that we care about for a certain component. We also tell it how to update certain parts of data received from the component on the server. And for example, with the SSH button, right now what we are going to do, we're going to access the reconciler, and then the reconciler is going to access the app state and the server. What's going to happen here is that the state updates that we were doing in one of the controllers, they become completely irrelevant. And there is a huge 1,000-line file, which is our API controllers, and this is just going to be deleted. This is going to be amazing. Data fetching is transparent for the application. So for example, we have, let's say we have an SSH key component, and it has a few properties. And the first time we fetch that key, we're going to fetch the ID, let's say, from the server. And then the next time it's going to be served from the local cache completely automatically. The fact that component data is defined as queries and is similar to GraphQL allows us to understand what data do components use. You know, sometimes we've seen cases where we pass the entire app state to a component and we have no idea what that uses. Here we are kind of trying to solve that problem if we use this, of course. We can also do HTTP caching out of the box because it's really easy to understand what kind of data do we need to fetch from the server every time, what kind of data we can store in the state and use it. We can also do optimistic updates really easily. So for example, if we have the same case, SSH key button, we make a request to the reconciler because the button was clicked. That shows the key right there in the project settings, and then sends the request to the server updating the key. Then the response from the server comes back, and we add the ID into the app state. And we have the key in some intermediate state before that. This also means that we're going to simplify unit testing in the front end, because right now we have a lot of WebDriver tests that just go in and click a bunch of buttons and expect some results to happen on the back end. With this, we will be able to take some kind of state and then parse the React tree resulting from that state. This is going to be amazing. Yeah, instead of like mocking all the APIs, we will just step out specific data points. Also means that we're going to do more efficient initial load because it just allows us to load less data, right? So that's how the reconciler is gonna change this all data fetching. There's also another thing that I'm pretty excited about. In OmNext, they introduced server-side rendering. So basically, in the same way that we were writing components previously, you can write a component on the backend and then render it to string, send it over, and React will just attach the listeners, and it's going to be it. It's going to be super, super fast. It's amazing. So with all this goodness, we're going to go and use new syntax for the components because it's backwards compatible, which is nice. We already use the new app state tree with all the query goodness. Then we're going to start to write actual queries that perform well, only fetch the data that we care about. Maybe we will implement GraphQL support, but that's still in the work, not even in the works, just in the talks. And yeah, this is the part I love the most. We'll just erase the whole 1,000-line files. Yeah, it's going to be great. So one warning though, OmNext is not production ready. So Om is production ready and we're using it. OmNext is officially not in the release stage yet, which doesn't mean that we're not going to use it in production, but you might want to wait until the release happens. So to recap all this thing, as I said, Om is really nice. OmNext introduces a lot of new features. You might want to give it a try. You can check out the documentation, play around with the examples. It's really easy to get started with the amount of the examples given in the documentation, the quality of the examples in there. And the good thing about Om is that the community is evolving constantly. And so Om as the framework is going to get better with time. We are going to contribute some things. Other people using it are investing a lot of resources in it, and so it's going to get better every day. Thank you very much. Time for questions now? Cool. What else can I tell you? Sure.
Do you think you can use the reconciler without using the OM, like using reagent or frame?
Yes. Okay, so the question was if you can potentially use the reconciler without using all other OM stuff, right? Rendering and all this stuff. So I don't think it makes too much sense to use that. You might be better off using Redux, for example, that implements its own reconciling mechanisms. Although if you try that out, I would be excited to see the result. Thank you. Sure.
I was wondering how well this interoperates with other JavaScript libraries. Is that something you just kind of include for the JavaScript? Or?
Yeah, so the question was if this is something that can be used easily with other JavaScript libraries. So it's fairly easy, I would say. So it's not super seamless, but it's good enough. So in one of the examples, I might be able to find it now. There is a way to just use JavaScript right there. Oh, here. This is a good one. Yeah, I'll fix it now. Give me a second. So here, why is it showing? Can I hear what? Do I choose? No, shit. No.
The top one.
Top one?
Yeah.
Okay. No, it just shows the browser.
Yeah.
It shows the browser.
It's just
No. Okay, never mind. So basically, yes, you can use JavaScript libraries right there. The mechanism of requiring JavaScript libraries is currently actively being worked at. It's not that you can mix JavaScript code and Klochay script code in the single file yet. But in theory, you could. Perfect. Thank you very much. So here, there is an example right there at the bottom. of using JavaScript calls. So this actually goes out to JavaScript and calls a function only available there.
Are there like definition files required to use a specific? Like, is there anything that checks that that render method exists, or do you just need
No.
to get it right?
No, you just need to get it right, yes. You can make some logic around that yourself so that you can only call like specific.
Not like definition files or
No.
anything like that.
Nope. Any other questions? Sure.
Can I debug the original source code in the browser?
Yes. So there are a few developer tools. One of them is Dirac, I think DIRAC, which allows you to trace error messages to ClosharScript files and not to compiled JavaScript files. So that's generally only possible in development environment. So you would not have that in production generally, just because all the code is very minified and no source maps are provided, whatever. But in development environment, yeah, we currently do that a lot. So I would say that it's not not in 100% of cases you will have that perfect traceability, but in most cases where the problem is actually with your code, you will have that visibility. Any other questions? Sure.
You mentioned some stuff about kind of interactive, like when you were developing it, it sounded almost like you were going to say do like hot reloading or something like that.
Yes. So the question was if you can do hot reloading and other cool stuff during development. Yes. One of the most popular development tools for ClosharScript is called Figwheel. It actually actively reloads all the code in the browser. So you update some ClosharScript, you update your component, bam, you have it right there, updated in your browser within maybe 1 second or even less. We also tweaked it to work with our less compilation mechanism. So when we update less, the same thing happens. Everything recompiles and it's instantly displayed in the browser. Any other questions? All right, thank you very much.